Physics. Obtain your day 4/5. Actually, it's going to be 5A. So you can change it to 5A. And we're going to look at the speed of light and light as a wave on this assignment. So you'll be taking notes. So obtain that paper and we'll get started. This should be the 20th, which is Thursday. And we'll see what's cooking. As you see, we've closed out our discussion on sound waves and we're turning our attention to light waves. The first thing up for grabs is the speed of light. The speed of light is going to be memorized this year if you have not memorized it in the past. So it'll be part of your memory work. And the speed of light is given in meters per second. 3.0 times 10 to the 8 meters per second. Right. So since we're not really thinking in meters per second, let's discuss just how quick that is. The speed of light is 3.0 times 10 to the 8 meters per second. So a meter is a little more than a yard, and if we recognize, we're going to move that decimal 8 positions. 1, 2, 3, 4, 5, 6, 7, 8. So 300 million meters in a second. 3 times 10 to the 8 meters per second. So let's take a trip. If we could be in a car and we could go around the world, say at 60 miles per hour the whole way, say there weren't any oceans or mountains to worry about, we could just go around the circumference of the Earth at 60 miles per hour non-stop. It would take us about 17 days to go around the Earth. Now sound, we learned several speeds for sound because it depends on the temperature. But let's say it's going to be at a constant temperature, and it would take about, depending on the temperature, but it would take about 24 hours to go around the world. So this is our trip around the world. Trip around the Earth. So sound, again, takes about 24 hours. And I was trying to remember what the degrees was for that. So it takes a little, at about 25 degrees Celsius. And that will take a little more than 24 hours to get around our trip around the Earth. So, in addition to that, guess how long it takes light to go around the world? Approximately 0.13 seconds. So, that's quite impressive, quite a difference. There's nothing else like it. So it's a little over 1/10 of a second. Sound can travel around the Earth. All right. Memorize this number. And I will not let you out of class next week unless you know it. All right. Generally speaking, let's talk about what light travels through, and whether, if you recall, when we were talking about sound waves, we found that in wood, sound traveled faster than it did in water, and faster than it did in air. So let's see how that works when we come to talk about light. It turns out that the speed of light waves change also depending on the medium through which they travel, But generally speaking, as the medium gets more dense, light waves, guess. I'll write it out while you're thinking. As the medium or substance gets more dense, light waves slow down. All right, just the opposite, as we saw that happen with the speed of sound. So let's do a problem that will actually work our minds and exercise us in finding the speed of sound or using the speed of sound. Suppose a physicist is watching a thunderstorm. So here's the thunderstorm, black cloud, little black rain cloud, and there's a flash of lightning, and the physicist sees the flash of lightning and then hears a thunderclap. So here's the ear, which must be present. He hears the thunderclap in the ear, and that took 1 second. So from the time she saw the flash, it was a second later that she heard the sound. Say the air temperature is cooled down, it's 15 degrees Celsius. How far away was the physicist from the lightning that was formed from the storm? So how far to the storm? All right. We're going to use our old friend from 4th, 5th, 6th grade. Distance equals velocity times time. And in this equation, we need to know, we're looking for how far, so we're looking for distance. And we've been well trained on how to find the velocity of the sound when the temperature is 15 degrees. So go off to the side and pull out that old friend. And plug in the 15 degrees. Alright, so go ahead and plug that in and get the velocity of the sound. The velocity of the sound, because we heard that in 1 second. So let's go ahead and find that out. So distance equals the velocity when you plugged it in. Did you get 340.6? And how long did it take? 1 second. So we end up with a distance, let's use 3 sig figs. So I would have reported this as 15.0. Let's go ahead then and use 3 sig figs, and we get 341 meters away. So the lightning therefore was formed 341 meters away from the physicist. So by measuring the time between when we see a lightning flash and when we hear the thunder, we can determine how far away the lightning was formed. And I was wondering if you ever did that in your life, because the speed of sound depends only slightly on temperature, and because 341 meters is how far that how far the sound went in 1 second. That's about 1/5 of a mile. So when you're watching a thunderstorm, you can use the general rule of thumb, and perhaps you already know it, that for every second of delay between lightning flash and thunder, the lightning was formed 1/5 of a mile away. And so we're not going to, if I ask you how to do these problems in physics class, this is just a general rule of thumb. I'm looking for more precision than that. But in your everyday life, if you see the lightning strike and you count, say, 5 seconds, 1001, 1002, 1003, 1004, 1005, if you count 5 seconds, that would be 1 mile away. So if you count 10 seconds, it's 2 miles away, and so forth. So that's a quick rule of thumb on how to know how close you are to the storm. All right, so would you please turn to page 367 and do Oyo's number 11.5 and 11.6. All right, so again, we're seeing something. So we're using light, where light is almost instantaneous when it's that close to us. And then we're hearing something a little bit later. That delay allows us to calculate distances. So use that principle and our old dear friend, distance equals velocity times time, in order to calculate some similar problems. 11.5 and 11.6 on page 367. So pause this video, go ahead and work those two problems. The answers are in the back of your mod. Let's see what page. 11.5 answer is on page 380. And 11.6 is on 381. I'm sorry. I said, is that an 8? Is 380 and 381. I'm zero challenged like Bree. All right, 380 and 381. No, you're not zero challenged, Bree. You're 8 challenged. Okay, 380 and 381. 11.5 and 11.6, and then pull this up again, and we'll go on. Part 2.